Okay, this is my Challenge 5 submission. I'm a little bit sick right now, it's cold, um, so my voice is a little bit off. But here's my lexical analyzer. First into tokens. Uh, oh, it's just for the notation of regular expressions. So something like this, checks whether it's valid or not. Um, then the tokens, most of them are going to be the same thing, like the brackets and stars and unions. Lambda, it's just these any other characters. We're going to assume they're input characters for the automaton that this would represent. Um, Here, terminal symbols or input characters. It's grammar or that. So, and we remove white space. And then here, um, this is just, I have a table that it's going to be producing as it through like you had in the slides, showing the stack and the remaining input. And here's my stack, and I just initialize it with this character saying we haven't received anything for E for empty, basic essentially, and then I print the stack and the remaining input here after asserting that, or for each. This is essentially for each input character. First, we assert that the stack is not empty, and then we print the current stack and input, remaining input, and then we pop items off the stack and the input, or we take the first input character, and then these I just have a bunch of cases as per this table here. So this is the token or the character we popped off the stack, and this is the input token. And then in here I either have what we're pushing onto the stack, or invalid, or subtracting the stack. This one, if we have this L here for a language, because a regular expression with parentheses can be defined recursively, and so I just use this to show that there was something there for when we close parentheses and use decline star. And this just says we're removing an extra item off the stack, which must be an opening bracket, and then we're putting this L back on, so it's valid again for the decline star. Because you can have a decline star just after a closing parenthesis. So this L just means it's valid language for that. And that's pretty self-explanatory, I think. And I just use assertions in here. This try that I have top, and if there's an assertion error, we return false. Here I just print the value of the stack and input again, remaining input again, and then return whether there was just one L for a valid language essentially on the stack, and that after removing that one, the length is 0. So here, print statements explaining the program, and then getting input while, and another input down here, same as my other programs. And then here I just tokenize the input string, lexical analyzer, and then run that parsing function with the tokens. And then if it's accepted, or if this comes back true, it's a valid regular expression, or the notation was valid, then we print it's a valid expression, otherwise I print invalid, or not valid regular expression. So let's run this. There we go. Okay. So I have this example here, as usual. Here, the tokens, as you can see, most of them are similar. It's just these other characters, these numbers are replaced with just an S. Here I have a stack. This initial item on the stack, and remaining input. Oops. So as we can see, we're taking these. If we get an opening bracket, then we just add it on. We get an S here, and then we add that as this here because that's a valid language. So then when we get to this Klein star, we know that that's also valid, and then the Klein closure is valid language as well. Another opening bracket onto here. And as you can see, if we get a Klein star or union here, we wouldn't have this L. As per the table, we would have an assertion error. We get this S here, union. This union represents that we had valid language. Otherwise, we'd get an assertion error when we get this union, and that we're just waiting for the next piece. And we got this opening bracket, and so we just then we add this opening bracket, and this union's taken care of. If there is a problem, it's because we're not closing parentheses or doing something else. But so far the notation is valid, and self-explanatory. There's the way that table, and here it's valid. And of course we can add an extra parenthesis or something. It's invalid because the stack was empty and we didn't have an opening bracket. We can remove one, and we can see we had an extra opening bracket on here, but we ran out of input. And same thing if we do something in the middle, similar. Then we have this, in this case we have this L and then union. Okay, so we need another input character or lambda or another sub-regular expression through the use of parentheses. But as you can see, we got a closing bracket or closing parentheses, so that's an invalid. And that's it.